Hi Chemistry, today we're going to go over 6.01 Stoichiometry and its uses. In this unit you will study the practical skills that any chemistry student, chemist, or chemical engineer needs to know. You will study the quantitative aspects of chemical reactions. Quantitative meaning how much. So we're going to look at how much stuff we start and end with to determine what's going on in the reactions. You will learn how to describe amounts of products and reactants in terms of mass, volume, number of particles, and moles. Moles, remember, is 6.022 times 10 to the 23rd of anything. Just like if I said you have a dozen eggs, you know you have 12 eggs. Well, if I had a mole of eggs, I'd have 6.022 times 10 to the 23rd eggs. You will interpret chemical reactions to calculate the amounts of reactants needed, the amounts of products produced, and the percent yields for any chemical reaction. Percent yield just means what percent did you actually create compared to what percent did you expect to create. All right, chemists use stoichiometry to calculate the amounts of reactants and products they need. Whether you bake a cake or make a new medicine, you have to figure out how much of each ingredient or reactant you need and how much of the product you will get when you are done. So in other words, when you bake a cake, you need to know you need 3 eggs, half a cup of oil, right? And you need to know how big the cake is that you're going to create, whether it's a 9 by 13 pan or whether you're going to make 2 dozen cupcakes. So it's the same idea with chemical reactions. It's how much stuff do we start with and how much do we end up with. This kind of figuring out is the focus of stoichiometry, and it is one of the most practical skills any chemist or chemical engineer uses. You will begin by learning what stoichiometry is, how it is used, as well as various ways to express the amounts of reactants and products. All right, so the goals for this lesson: to define stoichiometry, demonstrate understanding of the law of multiple proportions in chemical formulas, and describe some different ways of measuring matter. So stoichiometry is based upon the law of multiple proportions, where amounts are measured in many ways: the amount of atoms, the amount of molecules, the amount of mass, the amount of volume. Remember, mass is kind of like weight. Volume is how much space it takes up. All right. Baking a cake requires the correct amounts of ingredients to get the desired amount of product. Think about baking a cake. The proportions of ingredients are specified by the recipe and play an essential part in determining how the cake turns out. If you put in too much liquid, the result will be a soggy cake. If you keep the proportions right, though, you will have the correct amount of batter for one cake. Just as in baking a cake, chemical reactions consume reactants and yield products in definite proportions. Definite proportions just meaning that in the correct amount. Like I said, when you put all these ingredients together, you get one cake. Okay? So the reactants and the products, certain amount of products are created with certain amounts of reactants. A chemist, like a pastry chef, needs to keep the proportions and amounts right. The science of getting the amounts right is called stoichiometry. And we read down here, the recipe for a cake specifies the proportion of ingredients. Similarly, a balanced chemical equation specifies the proportions of reactants and products in a chemical reaction. Okay, now we need to take some notes. Okay, I went back to this first slide and I downloaded the study guide. You can use the study guide, or if you want, you can just make your own Word document. And what I did is I just put my title. Here's the lesson that we're doing. And then I put down the keywords and pronunciations. However, I added a few things on my sheet that I felt were important. So please be sure you're using the pause button and add things that you also feel are important. So I'm putting them in red. So the mole is an SI unit. SI means System International, which is international system or metrics. Okay, so it's a metric unit of the amount of substance. Specifically, it's 6.022 times 10 to the 23rd of something. Okay, the next word is product. It's the result or the new substance from a chemical reaction, product has different chemical and physical properties from the reactant or reactants, and I added an example. It's always good to have examples in your notes so you can quickly refer back to them. So in the chemical equation, H2 plus O2 yields H2O. The product is water. The next word is reactant. In a chemical reaction, an original substance that undergoes a chemical change. Now I use the exact same example, but this time I told you the reactants were H2 and O2. Then we also have stoichiometry. We have two definitions for stoichiometry. The first one is the study of determining the yields or the amount of chemical reaction given the masses and some parts of the chemical equation. And another definition, or kind of the second definition, is the branch of chemistry that examines the quantitative or numerical or how much relationship between components or parts in a chemical reaction. All right. Next slide. Performing a chemical reaction requires the correct amounts of reactants to get the desired amount of product. If we go back here, you might have noticed that, hey, this is not balanced. This is where balancing comes into play. We have to make sure everything is balanced. I have 2 oxygens on my reactant side, but only 1 on my product side. So what do I need to do? I need to put a coefficient of a 2 right there because now I distribute. I have 2 times 2 is 4 hydrogens. 2 times 1 is 2 oxygens. Now my hydrogens are not balanced because I have 4 hydrogens on my product side and only 2 on my reactant side. So what number do I need to put right there? A 2. And now my reaction is balanced. And that is very important for stoichiometry, having a balanced chemical equation. All right. Consider a chemical such as plastic resin or a new medicine. Before the chemical appears on the market, a chemist produces it in the laboratory. Because reactants cost money, the chemist does not want to waste materials. Furthermore, he requires the reaction to have the best yield for the amount of reactants used. Otherwise, making the product might cost more than the product is worth on the market, which of course would not be profitable for the company. The chemist has to work out a balanced chemical equation that represents the exact chemical reaction. With that equation, he figures out how much of a reactant to use and how much product is to be made. He then combines reactants to get the desired product and the correct amount of that product. Okay, so main idea is basically this sentence. So performing a chemical reaction requires the correct amount of the reactants to get the desired amount of the product. So I'm going to add in there, we don't waste chemicals as they are expensive. Okay. Stoichiometry is the science of using the right amount of reactants to get the right amount of products. So let's look at the picture. Stoichiometry takes advantage of the balances in amounts of reactant and product to help answer the question, how much? Stoichiometry is the branch of chemistry that examines the quantitative or numerical relationship between components in a chemical reaction. The word stoichiometry was coined from Greek words meaning element and measure. It is the branch of chemistry that you use when you figure out how much to use and how much you will get. Okay, so we'll add a little bit to our notes. And of course, you can choose to write different notes. You can choose to write a little bit more, a little bit less. To use the right ratio of reactants to products, chemists start with a balanced equation. This is so important. It's like rule number 1. Okay, so in fact, I'm going to bold this one because it is so important. So in your notes, you may want to do the same. A balanced chemical equation shows how many units of each atom, molecule, or formula unit are present in both the reactants and the products. The coefficient shows how many copies of each molecule or formula unit are present. If there is no coefficient, a coefficient of 1 is assumed. Okay, so let's look here. We put a 2 in front of our H2, and we put nothing in front of the O2. So we assume that there's a 1 there. Just like in math class, when you write X, you know that it means 1X. It's the same idea. And then, of course, there's a coefficient of 2 in front of the water, meaning that there's 2 copies of that water. The subscripts show how many atoms are in each molecule or formula unit. If there is no subscript, again, a subscript of 1 is assumed. So the little numbers are subscript. There's 2 H's in water. There's 1 oxygen in every water. The equation is balanced if there are equal numbers of each type of atom on the left and right sides of the reaction arrow. For example, 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to form 2 molecules of water. All right, so let's look at how they got that. 2 copies of H2, or in other words, 2 molecules of H2, react with 1 molecule of O2. It yields or produces 2 copies of water, or 2 molecules of H2O. We also know that there are 4 hydrogen atoms on each side, because 2 times 2 is 4. 2 times 2 is 4. And there's 2 oxygens on each side. 2. And again, we have to distribute this 2 over here, so there's 2 oxygen. A balanced equation represents the law of conservation of mass. In any chemical or physical change or reaction, mass matter cannot be created or destroyed. Okay, what I did is I copied this into the notes, and then I wrote a little bit about it. So let's look at the notes that I took. So this is what I copied about the coefficients and the subscripts. Then what I did is I wrote our chemical equation, and I changed some numbers to be purple. Here's why. Because when I read it, it says 2 molecules of H2. That's represented by the fact that here's H2, and there's 2 copies of it. That's what the coefficient tells us, how many copies there are of each. So 2 molecules of H2 react with 1 molecule of O2. Notice my 1 is in purple. If I wanted, I could put that same 1 right here. I do not have to, but I could. All right? And that makes 2 molecules of water. Again, I change it to purples to remind you that that's what the coefficient tells us. And in my diagram, there's 2 copies of the water. We can easily see when I drew it that there's 4 blue hydrogens on each side and 2 red oxygens on each side. We know that from the equation because 2 times 2 is 4. 1 times 2 is 2. Hydrogens, again, 2 times 2 is 4. And 2, we got to distribute it over to our oxygen, gives us a total of 2 oxygens on the product side as well. All right, and then I'm going to copy this last sentence because that's super important too. That's the why all of this works. It all works because of the law of conservation of mass. So you have to have equal amounts of everything on both sides. All right, and I'm going to pause the recording here because I can only make them 15 minutes long. And so we will finish up this lesson in the next recording. So again, I'll put up the notes, so go ahead and pause it and make sure you got everything you need. And then I'll scroll up. Go ahead and pause it. Oops. And make sure you have everything you need. So here's the first part of the notes again. And then the last part of the notes. And then we'll continue with the next recording.